Yeah, I'm going to start, right? So, hi all, I'm Ricardo, and I'm going to talk about the DBI for computer security, uses and comparative. So first of all, let me say that this work has been done by one of my undergraduate students, Juan Antonio Artal, and also with my PhD advisor, Jose Mercedes. Okay. So first of all, let me also introduce myself. I'm from a small city in a very good country, Spain, you know. From Zaragoza, we have a lot of things. I also spend my time in a very small town in Teruel, Montalban. Okay, and after this small disclaimer, let me continue. I'm a member of Crack Latinos group. It's a cracking group since the early beginnings of the 2000. I'm currently a PhD student at the University of Zaragoza. Currently, I'm working for the Technical University of Madrid, working in all this stuff, mainly doing safety analysis in company-based systems, but this is another field. And my PhD bye-bye is the next Monday, so cross fingers for that. And we are going to see some demos in this talk. All of them has been developed with the GPL version 3 license. Some are under the Intel open source license, and each one of the licenses is specified in each one of the source files. And everything is available, so the demos and also these slides in this URL you can access from the QR, and you can, trust me, there is no any add-ons on the PDF, I think. So, this is the outline of the talk. First, I'm going to talk a bit about what is DBI, how does it work, and the main uses you can do for computer security. Then I will move to what is a DBI framework, okay? The types of DBI frameworks that we can find on the internet, and the analysis and the comparative that we have performed. Then I will show you some demos about how we can apply the DBI to computer security, mainly for looking vulnerabilities and for doing some timed analysis and for reverse engineering. After that, the conclusions and the acknowledgements. So moving to the business, what is DBI? DBI stands for Dynamic Binary Instrumentation. So the main words here are instrumentation, dynamic, and binary, okay? So what is instrumentation? So attending to the definition of Galdiskin, instrumentation can be defined as being able to observe, monitor, and modify the behavior of a computer program, okay? Some other guys say that instrumentation means the arbitrary addition of code in binaries to collect some kind of information. So I have mixed these two definitions. So instrumentation can be defined as analyze and control everything around a binary code, an executable code, by means of collecting some information and adding some arbitrary code during the running of the executable. So instrumentation means what is happening, okay? What about dynamic? We have two kinds of code analysis. Either static, that means that we are going to analyze the code before the execution. In this case, we are analyzing all the possible execution paths of our binary. So this is not extremely good for the performance. The more paths you have, the more time you will spend, so not so good. Dynamic, however, is done during the execution. In this case, you only analyze one execution path. This path may depend on the input data given by the user. So dynamic means that we are doing everything during the execution. And about binary, so we can perform different kind of dynamic analysis. Either if we have the source code, we have two choices. Maybe we can instrument somehow the own source code by adding our tricks. The compiler can do it for us by us. If we don't have the source code, that is more or less the common case, We can either to instrument the binary in a static way. This means that each time we want to instrument, we need to create a new binary with some extras, or we can do it in the dynamic way. We can also depend in the environment by using emulation or virtualization, or we can just make some debugging. Okay? So binary is referred to the code of a binary or an executable code in this case in Windows. Okay? So what are the main advantages of having binary instrumentation? Well, we are totally independent of the programming language of the binary. It doesn't matter if it was compiled with Visual Basic or C++ or whatever. We have a machine mode vision. This could be an advantage or a disadvantage. It depends if you talk assembly or not. And we can instrument any kind of software. I mean, your own software or proprietary software. The advantages of using dynamic instrumentation are mainly that we don't need to recompile or relink each time the binary. It allows us to find on-the-fly code, so dynamically generated code, and we can able to instrument a process which is already in execution, so using the attach. Okay. So, however, DBI is not Wonderland. We have few disadvantages, mainly that we are introducing some overhead. This overhead is done by the instrumentation during the execution, and this will produce a very high impact on the performance. So this can be a very pain in the ass for the analyst. Okay. So how does DBA work? Recall that we have said that we can add any arbitrary code during the execution of a binary. So we will have here our running code of our binary, and we need to define what do I want to insert. Okay, this is done by a thing that is called the instrumentation function. So with this thing, we can define what we want to insert, and then we have to define the places. Okay, where we want to add this code. So for instance, we have our binary, and I can say, okay, I want you to execute this code only in this point and only in this point. Okay. So an informal definition of where is the DBI in the context of dynamic analysis. So DBI gives us an executable transformation, the total control over the execution of the binary, and we don't need to have architectural support. Okay. So in contrast with virtualization, virtualization doesn't have total control on the binary. With emulation, it doesn't give us a real executable transformation. And with debugging, we need architectural support. So let me comment you some first non-security uses of DBI, mainly code coverage and metrics, call graphs generation, memory leaks detection, instruction profiling, data dependency, threats profiling, race condition detection. Also in computer architecture, if you are more related to this field, DBI is commonly used for generating trace for memory traces, for making branch and cache predictors, so for memory failures recovery, and for simulation of speculation strategies. So everything that you need to test or research, these things are using DBI, okay, and so on and so forth. More security related, for instance, data control flow analysis, vulnerability detection, this is the one that we are going to do in the demo, test case or phasing generation, advanced monitoring like the NSA, reverse engineering, or privacy monitoring, sandboxing, and everything that you can think from here. So let me comment you some of the tools that already are using DBI somehow. For instance, for vulnerability search, we have Sage of Microsoft, Socrates, Fullscreen, Avalanche, Determine, Pinkov, TimeDrought, Vera, TraceSurfer, etc. Okay, the DBA I use in computer security is its popularity is in crescendo. So we have a lot of, you can check on the internet. I have just put here a few of presentation related somehow to DBI. And let's move to the second point. What is a DBI framework? Well, a DBI framework is a tool that allows you or gives you a bunch of functions or API for tool development. The tools that are developed with this DBI framework are called DBI, Dynamic Binary Analysis Tool. And we have different types. It can be lightweight or heavyweight. The main difference is that the heavyweight use some intermediate code. We will see an example later. And the main components of a DBA framework are, we have a core that usually is a just-in-time compiler. That is who is controlling the execution of your binary. And then we have our library. Okay, this is the thing that you develop, and here is where you define what you want to instrument and the places where you want to instrument. Okay, usually a DBA framework is called in this way. So you will invoke the framework core, then you will put your library, and after that the binary to be instrumented. The most common use modes in DBI are just-in-time, where we have a modification of a very small set of instructions before executing them. In this case, this mode is more robust, and it's very good for repetitive behaviors, for instance, for loops. Why? Is because this small set of instructions are stored in an instruction cache, so each time is needed, you have already modified, you don't need to modify the instruction again. Okay. The other mode is the probe. In this case, you are doing a memory patching. This is less overhead. It executes native code, but however, this is not supported by all the DBA frameworks that are available currently. Lastly, let me comment you that there is different granularities, more coarse or more fine. So we can either go to the instructions or either go to the routines or to the image that is more bigger. Okay, so we have either a very fine or more coarse granularity. However, some of them are not supported in some of the DBI frameworks. So, for instance, what are currently the DBI frameworks that we have available on the internet? Just this, for naming a few. The more known are these three of here, at least for as far as I know. So we can ask, okay, if we take these three, for instance, what is much better? This is the question that we have tried to answer in this research. So let me comment that as selection criteria, why we have selected this. Indeed, we have followed this criteria, mainly that the software is being maintained actually, that the license gives access to the source code, that we have, it's free for use. There is some kind of API to be able to develop some DBA dynamic binary analysis tool, and we have also looked for operative system and common infrastructure in order to be able to compare. So we have focused in Valgrind. Valgrind is were done in a PhD thesis in the University of Cambridge. The source code is available with the GPL version 2 license. However, Valgrind is using an intermediate code. Indeed, it's Vex IR. So it's provoking the heavyweight DBAs. And it only supports the instruction and the superblock granularity. Okay, so all the supported architectures are these ones, and the operative systems, Linux, MacOS, and also Android. Okay, the other one, PIN, this one is developed by Intel. We have the source code available, but however the license is proprietary. And one interesting thing of this DBI framework is that it allows us to attach a process during execution. You can check on this website if you want to download it. And you can see also that this DBI framework provides us all, more or less, all the granularities. Okay. Finally, Dynamo Rio, which is being developed by MIT, HP, and I think that recently has been bought by Google, or is collaborating somehow. The source code is also available under the BSD2 license, and it has a really good documentation. And however, doesn't use all the granularities. Okay. So just for commenting some similarities between them, we can the injected code that we can add to our the binaries has to be done in C or C++. We don't need to have the source code of the binaries to be instrumented, and all of them allow us to execute in Linux. So let me comment you what we have done for the comparative. We have developed a tool that it's very naive, so it only counts the number of instructions that are going to be executed, but we have used two granularities, mainly the instructions and the basic blocks. A basic block is defined as a small set of instructions. So imagine, for instance, in assembler until a jump or a count, so this will be a basic block. The main comparative has been to evaluate the performance of the selected DBI frameworks commented previously, and we have defined the slowdown as the ratio between the time of being instrumented and the time not being instrumented, okay, the time that takes in execution. So just for commenting, while we were developing this, we have dived into the functions of each one of these DBI frameworks, and just for commenting that Ping has very good examples, Dynamo Rio has very good documentation, and Valgrind, okay, is the loser here, but it's not a bad tool. As experimental settings, I'm not going to enter, but we have used these machines, so with this configuration, and yeah. As benchmark, we consider to use some of the common benchmark, for instance, spec, but spec was discarded because spec you have to pay for use it. So we develop our own benchmark by taking some of the binaries that are used in the spec benchmark, and mainly we have defined it in our benchmark different categories. So we are interested in binaries of integer computation, float computation, that the binaries that make a high use of input-output, and the use of memory, okay? So this is the results of the comparative. So sorry for the bad resolutions, but it's also in Spanish because I don't have the vectorial graph, so I can't change it. So let me comment you that here we have the memory consumations in megabits, okay, and here we have all the binaries that are in our benchmark, some of them. So just for showing that here we have the memory consummation of Dynamo Rio, okay, and here we have the memory consummation of Valgrind for each one of the binaries. Also here we have the pin, and of course here we have the execution without instrumentation. As expected, is the fastest one, or sorry, the smallest size of memory. So about the slowdown by instrumentations, comparing the two of the granularities that we have considered, we can see a very high difference between the benchmarks. Between the DBI frameworks. Okay, so here we have that we have tested all the binaries using optimization and level optimization of 0 or at a level optimization of 3. So we can check that we have here a very high slowdown for Valgrind, and also in the case of having the higher optimization. Indeed, they are more or less the same. Okay. So, as conclusion of this comparative, let me tell you that if you want to run optimized code or binaries that are doing a very high computation with integer floats, you should use DynamoRio. The slower solution we have seen that is bar green, and if you have some memory constraints, maybe you should use PIN instead of using DynamoRio. Okay. Some funny things that we have discovered during this research is that the number of instructions, you think that maybe they should be the same. So you have the same binary, you are counting the instructions, they should be the same, right? Well, but this is not. The number of instructions differs among each one of the DBI frameworks, and this is because each one of these DBI frameworks starts to instrument in a different point. Okay. We also detected a bug in Valgrind related to a function that runs the 80-bit numbers in both architectures, but unfortunately it was already reported, so we cannot put the signal. Anyway, let me say that if you are interested in this, there is a technical report of my student that is this one. I'm sorry to say that it's in Spanish. We should write some paper on this soon, but I don't know. Okay. Anyway, you can use Google Translator or just ask me. Okay. So you can download it from here. Well, let me go to the really important thing. Let's go to apply dynamic binary instrumentation to computer security. So let me comment that I have used PIN. PIN is composed by a set of this set of things of here. So we have a virtual machine, a code cache, and also the what is called the API instrumentation. Okay, all the tools that are developed with the PIN are called PIN tool. It's very easy. And let me comment how does it work. Okay, first we have the virtual machine that is composed by the just-in-time compiler, an emulator, and a dispatcher. Okay, so the first thing that the just-in-time compiler does is take your binary, compile it, and add the instrumentation that you have defined. Then these instructions are sent to the dispatcher and are stored in the code cache. Okay, the dispatcher already executes and everything. So as I was saying before, as these are stored in the code cache, if you have some loops or something like that, so you have already your code instrumented, so you are not losing more time in instrumenting again. And let me comment if you want to know that this works in the operative system level. So, sorry, it's working in the user space level. Okay, so not in the kernel. As an example, let me comment one of the examples that is provided with PIN. This is just counting the number of instructions that are going to be executed. So mainly in your main typical main of C code, you need to define, you need to put you need to call to this function, and then you only have to add to call to the instrumentation function that you want to define. In this case, they are defining a function in the level of instructions, or in the granularity of the instructions. That is this instruction that if you see, we have it here. So we are saying that we want to insert here, insert a call, okay? Insert in each instructions before executing, you have to do these functions, do count, okay? Do count is just a counter. So each time an instruction is going to be executed before this function is called, so a counter is incremented, okay? So mainly this is the instrumentation function, and you also will need to add these things over here. Well, let's go to the business. So first of all, I have developed a tool that is this one, double-free DBI, okay? I'm trying to look for the double-free vulnerability. This vulnerability is defined with this number, okay, if you check this website. So it's basically, if you call free twice with the same memory address, you can corrupt the memory, okay? And this can provoke, as is said here, Doubly free in memory may result in a write what where condition, allowing an attacker to execute some arbitrary code. Okay, so my tool, what is going to do? I'm going to hook the functions of Windows that are related to the asking of memory and the allocation of memory and the release of memory. Okay, so we are going to instrument this function after and this function before. Okay, and what I'm going to do is very easy. So after calling the allocation of memory, I'm going to keep the address of the memory that I have that the system has provided me in a list, and after releasing the memory, I'm going to I'm going to remove that address from the list, and if the address that is given to me, if it's not in my list, I can report that maybe I have found a vulnerability. Okay, so let me go to the funny thing. Okay. Yeah. So this one, yeah. Yeah, I'm going to compile if you want to check that I'm not lying. Okay, works. Good for now. So I'm going to call just my pin framework, as I tell you. This is the way to do it in Windows. Okay, I invoke the pin DBI framework, and I have to give it my tool that is double free DBI. All of these things, as I was saying, is okay. I have here the code if you want to check after or something like that, but are on my website. Okay. So yeah, I was telling that I have here this and the binary. So it's this one, okay? Yep. So this is going to do the things that we have commented. This is an example. Oh, let me show you if you want. Well, after that. This is exploiting the double free vulnerability. Well, it's just doing two frees, two calls to releasing the memory with the same address, okay? And my tool has detected that it seems that we got a free of an unallocated address, okay? So, and it's also reporting about where this has happened and the address that has been released twice. So if you want to, yes. Okay. So just if you want to check. So this code is not mine, it's taken from the internet, but anyway. So here you have two frees, okay, of the same pointer. So let's move to the next. You have some question or something? I can stop anyway, anytime. Huh? So yeah, I have already made it. Thank you. So next, I have focus now in the buffer, in the typical buffer overflow. Define it with this number, okay? So you know that if we are copying buffers without taking into account the limits, we can have some arbitrary code execution. You know that, right? So buffer overflows often can be used to execute arbitrary code, blah, 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 generally lead to crashes, okay? In this case, what have I done is my tool works around the scanf functions, okay, the typical function of in C for parsing the input of the user. And I have defined that before calling this function, I'm going to make something. What I'm going to do is just check the parameters, checking, but for buffers that are not being limited somehow. Of course, this tool could be extended to other vulnerable functions, such as string copy and these things. Okay, let me show you. Yep. Let me comment you first. This is the. Let me do it bigger. Okay. Yeah. So just the main, I have just a printf. I'm calling a procedure, typical, okay. This procedure has a local variable, and I'm just asking the user for his name or her name, and I just reading it, okay. After that, I will print the name. Everything is fine, right? Cool. I'm on time, I think. So let me check. Yeah. I'm gonna compile again if you want. Yeah, here we have. Okay, I have compiled my vulnerable program. I'm going to execute it. Enter your surname. Okay, my name is school, I know. Yeah. So everything works perfectly, it seems. Okay, let me check if we have some vulnerability in this binary. I have prepared a pair of cell codes, so let me execute the first. Okay, so as you know, this local variable is producing that if the input is bigger than the size of this variable, we are going to rewrite all the stack, okay, until this returns, so we are getting a buffer overflow. Let me show you the cell code. Yes. So we are able to give in a very high, a defined input. So we are able to launch the calc windows of the windows, okay? But we can also do more things. So I have another cell code. I can provoke a message or whatever you want. Okay, this hacking comparative rocks. Let's hack out together and these things. So continuing with the vulnerabilities. Yes. We can also check for, yeah, I've already done. We can improve this this tool, and we can try to protect somehow the return address to avoid the buffer exploitation, okay? So we are going now to do another tool, which is called protect red address DBI. And this tool is going to, what it's going to do is every call before or every return before in the text section are going to be instrumented, okay? And what I'm going to do is each time I'm going to find a call, I will store the legitimate return address, can be computed with this formula, and each time I found a return, I will check if the return address matches with the one that is in the list, okay? One funny thing is, as you will see, is that we have detected 6 return changes in this library, okay? So by default, by Windows. Funny thing. Let me show you. Oh, I didn't show you the buffer overflow. Sorry, my fault. Yeah. Let me show you the one of before. Yeah. Yeah, well, if we do this, okay, this is the program ending normally. This DBI is writing everything in a log file that is called bufferoverflow.out. So if we check, it says that we have a possible scanf vulnerable found in this address, okay? Sorry, this is the previous one, I forgot it. So moving to the one that I was talking about. Protect, yeah. This one is going to do more or less the same, but it's going to try to protect our return address to be avoiding to be exploited, okay? So if we execute in a normal way, this is the one that I told you, okay? my tool is informing that the return address has been modified. This is quite curious. Okay, you see this all matches with the NTDLL library. So this works fine. Okay, if I give this executable the cell code, we will see that it breaks. Okay, but breaks because we are trying to execute the stack and pin doesn't like it. So, but here you have the report of my tool. Okay, the tool is saying that the return address has been modified in this address and has been moved to this one. Okay. So continue. Yes. Yeah. Last one. No. Before the last one. Time analysis. We can also make time analysis of all the parameters that you want. In this case, I have developed a tool for doing time analysis of the scanf parameters. So I have defined that I want to instrument the scanf function after, and what I'm going to do is just trace all the register, all the memory zones that are contaminated somehow from the given input data. Okay. So let me show you. I will kill this because it takes very long. But okay, same as before. I put this, put my tool. Oh fuck. And oh, I haven't compiled. Fuck. Sorry. I know. It was only foreseen if you were attending. Thank you. Okay, this thing is doing something. Okay, in the behind. Oh fuck! This is not the one I want to show you. Shit. Yeah, I will pay you a beer for each bad word I say. I know. Yeah, this is doing something. Blah. Oh, fuck. Fuck again. Yeah, well, anyway, let me... Do you know how can I come back to the small window? Okay. Anyway, I have here the output. Okay, is this one. Let me show you. Yeah. Here we have, okay, the input of the user is being recorded. So we have here a register to memory movement, register to memory, blah, blah, blah. Okay. So with this trace, you will be able to know where is your data going on, okay? So, before continuing, yeah. Last one is related to the reverse engineering, a very nice example just for showing it. So, I have developed a tool, and what I'm going to do is just a typical tool that is asking you for a password, okay? And the idea is to try to look for the correct key inside the binary. So I'm going to do a hook in the string comparison of function of Windows. Okay, that is this one of here. It's very used in the binaries. I'm going to instrument it before, and what I'm going to do is just log all the parameters of this function. Okay. So, okay, this could not be longer valid for the current application, isn't it? It depends. Okay, let me show you. I'm going to do here the trick. Yeah. Okay, so we have here an X, enter password to unlock, blah, blah, blah. access denied. Okay. Let me instrument it with my tool. Yep. And yeah. And it's called easy quick. Yep. Enter power to unlock. Ha ha ha. Yep. Access denied. As before, I have just put it everything in a file. Okay. So now, if we check that file, we will see that this function has been called in this address. The input data of the user, or well, more or less, the input parameters were this one, the one given by the user, and the other one. Okay. So as you see, we have everything. So yeah. Well, let me finish with the conclusions. DBI frameworks are very good. You can develop in a very fast and in a very easy way a lot of tools with a very high potential, so you can do everything you want. There is no need, or not too much, of knowing, of having advanced knowledge in the operative system programming, so how the operative system works. Depends on the kind of tools that you want to do. And one benefit of the DBI frameworks is you just can focus on what really matters, that is, what you want to do, okay? Main disadvantages is that, of course, you will need to know the functions of the DBI, and of course, the execution time, okay? Recall that we have seen the frameworks comparison. If you want to run optimized code or the ones that use high computation in integers or floats, you need to use this. Barring is the slowest solution, and for memory consumption, if you are interested in having less memory, so the better is spin. Okay, and acknowledges. Thank you, Aldiskin, Dimitri, you're here, and all of these people that has helped me in their research. Hacking Paris staff, thank you, guys and girls, and to you for hearing me stoically. And that's all, guys. If you have some questions. Any question? Is all clear? Cool. Thank you.